Ladies and gentlemen, hi, I am Evgenij Vinogradov and I am working for Yandex Money. We are developing a payment system that will be important for you to understand the presentation, because my examples, my use cases, my presentation is all about algorithms of data storage in the payment systems, although it can be expanded to other systems, from history to vectors, how we built the scoring system, scoring in real time. Let's start with scoring. What is scoring? Who knows that? Raise your hands. A few people. So let me tell you a few things, what we're talking about. Scoring is something that is well known from ancient times. As soon as human beings appeared, even before human beings, scoring looked like that. It's fight or flee, fast decision making. We have to see whether we can win or whether we have to escape. For thousands of years, scoring was born in the same in this kind of situation. Uh, and for many years, nothing new has appeared until 1936. This iris flower played an important role for the development of data mining and data science, because in 1936 Mr. Fisher published an article where he showed that this sorts of iris can be defined by secondary features. So secondary features is a step forward, but a few years later, Mr. Duran moved further. He realized that loans and irises are almost the same, and we can use secondary features, factors, by evaluating the person who wants to take a loan. So we started from loans, but actually didn't confine itself to loans. We can count whether the counteragent is good or bad, whether a person you work with is good or bad. It depends. It all relates to security. In our case, in the payment system, security is fraud, means fighting fraud, and we have to see whether a person we talk to is a fraudster or just a normal customer. Uh, we can also mention authentication. Fingerprints is just one of the possible options. Authentication of people and devices is a wide range of operations for data mining. For example, counterfeit money detection, uh, data mining can be used for that purpose as well. Then we use scoring for insurance. When you want to insure your car, the underwriter looks at your history, how often you used insurance before, and gives you a number of points to define your insurance premium. Scoring can be used in many cases. Today I will show you this kind of use case. Why do we need it? We have a lot of users. Some of them are powerful, some are not. Some people are involved in a lot of operations, other not. When we see a transaction that we have to process, we have to understand whether a person who is the real person that he claims to be. Is he an imposter or not? In this, at this moment, we calculate scoring. What is the probability of the operation belonging to a person that he claims to be? We build a picture or a portrait of a user, of a phone. We know that operations with this device looks like this. We use addresses. Usually operations from this address look like this. So we have a lot of features, a lot of factors. And at the moment of operation, we have to evaluate the person and the operation very fast, in nearly real time. The profiles can be of two types: static and dynamic. In credit scoring, a priori and a posteriori profiles a profile can be calculated once and forever. For credit scoring, we use the national poll data or some other data, census data, and then we see whether a person speaks the truth or not, whether his data contradicts the general profile or not. But in the modern world, change is fast, and the profile can become obsolete in a matter of hours, if not minutes. We never use such kind of profiles anymore. Dynamic profiles are recalculated with every transaction. It contains fresh data, because end user behavior can change within 21 days. 21 days it takes for a person to get new habits within 21 days. So we have to renew, refine, recalculate the profiles. Here we have a lot of challenges related to performance, speed of processing, speed of adaptation, and I'll tell you how we solve those problems. What did we start from? We had to build a scoring system to define the truth from lie. We developed a mechanism. We took a history of transactions. We saved all transaction data. When we wanted to see the scoring of a new transaction, the operation, what kind of operation, destination, origin, amount, and in real time through SQL queries we built a profile, and as a result we took a decision. We classified the transaction, we saved the transaction in history, and took a decision. That kind of system was good for recording data. Latest transaction data have always been available. And secondly, if initially when we developed rules and algorithms, we didn't take into account a certain parameter, and then sometime later we said, oh god, this parameter is truly critical, we could quickly and cheaply insert this parameter because we had all the history. The only drawback is performance. The system was growing, we had more and more operations recorded, then SQL queries stopped satisfying us, and we had to change the architecture. We defined a number of requirements to satisfy. Here they are. First of all, high speed of processing, taking into account the volume of operations. Then we had to modify profiles very fast indeed. When we learn something new, we must be able to make changes as fast as possible without a lot of development effort. Scalability must be supported, so we shouldn't start from scratch building a new system when something changes. We would be able to add and expand. And point 4 is last but not least, it's data volume. I'll tell you later about the volume, but in any highly loaded storage, well, the bigger is the volume, the more problems with performance you have. It's quite obvious. If you have a certain budget for hardware procurement, you can buy a lot of disks, slow ones, or fewer disks, but they will be faster. And if the system is faster, then you have less performance, fewer performance with performance. I'll tell you later about it. What is the conclusion? The first one that we realized is that history is not feasible any longer. we don't have to take everything into account while calculating the profile, but we have to store data somewhere. So we have to save profiles. That was the solution. We don't have to recalculate them each time, but we have to use ready-made existing profiles. The next point is that scoring of current transactions and recalculation of profiles should be carried out synchronously in parallel. And each time we must be sure that all our storage is ready to recalculate the new profile and process a new transaction. Now, let me tell you how we built it and what kind of solutions we used. Well, a profile means three things. It's our perception of how a person or a device behaves usually. A person or a phone or an address or a region, any entity. For example, in different regions they do transactions at different hours because of the time zones. China and the Russian Far East have the same time zone, but western parts of Russia is a different time zone. So profile is a combination of three things. First is type, second is key, and point three is vector, our knowledge of the object. The search is done by a combination of type and key. No aggregated queries, only one option. What is the bonus? What is the value? The key search by key can be done very fast. MySQL, MS SQL, Hadoop. Search by key is available everywhere. Then we have to save other attributes in some kind of form. Initially, the vector contained all profile attributes, but numerical data is not sufficient. It may have this kind of structure. It's one of the phone profiles. These are the objects, payments and links. We have details about payments, last payment, volume of payment, and we save this data in this kind of form. Then the main purpose of the profile is as follows. At the moment of operation, we deserialize all this. The storage of format is XML, but this is not an absolute must. We can use JSON. It's not obligatory. The next point is a system of rules. Synchronous calculation of scoring and saving the profile. I'm not going into detail now. We use business rule engine, BRE, a set of scripts where on your left we have calculations or checking the conditions, and on your right we have saving the profile or the scoring data. We can have a lot of rules. Addition of any new rule doesn't affect your general performance. In some cases, well, we have to read the profile to apply the rule, because if you have to use the rule, you have to read it from somewhere. So left part is calculation, the right part is update of profile, update of scoring. If you have no profile, we have to create it. Quite often we have an operation with a profile, we don't know it. For example, a person opened an account and uses it for the first time, or he bought a new phone. We don't have non-existing profiles, we do not create anything in advance. If we have an unknown operation, we build a profile from scratch. Lack of empty profiles saves our time while calculating, because we always know where the key is. How does it work? Today, the system works as follows. A query comes to the rule engine. Below, we have a profile storage. We read appropriate profiles. Then we calculate the scoring. We save the results. If nothing has changed, we save nothing. We save only the changes, and we give away the result. History actually is needed. It is not always needed for calculations, but actually history must be saved in all relation system. And history is stored in some other place, in some arbitrary or ambiguous cases. Keys, as I said, I will tell you more about the keys. So here you are. Keys are critical. I believe that we have to use natural keys. No surrogate identifiers. Use what you get from transaction itself. Then you can have such keys as the current account, the phone, the address plus account. An additional benefit of the keys for performance and scalability is sharding. So your storage shouldn't be always monolithic. You can distribute it. Sharding is an art rather than a science, and each time you have to define how to shard your database. The keys helps you to link the database to certain realities of the world. So from Russia we get more operations than from the rest of the world, which is only natural for us. Then we have to put a very powerful server to store Russian transactions. From Latin America we have much fewer transactions, so we can keep it far away. US is somewhere in the middle. So you can divide your transactions by geography. Then you can divide them by mathematical features. For example, a phone is a certain random number. If you can take the last 4 figures and simple mathematics can divide phone numbers in different storage places for them not to intersect. And of course, each and every time you have to see what loads your storage to the most and how to divide that kind of workload. Next point is about the volume. I also promised to tell you more about the volume. What do we do with the volumes? First of all, we read and write only profiles. So we minimize operations of read and write. There is a drawback here to put those. It's impossible to put all those profiles into the history of operations because we sometimes lose some data, but we can solve that problem through external storage. But for the calculations we don't need anything else. What we save only something that we need. The second point is we don't have to store something that we don't actually need. In each profile we have a lifetime. In a year, in 2-3 years, end user behavior changes drastically. We can find it empirically. In some cases it's a legislative requirement. In other cases, for example, if you don't use your phone number, mobile operators resell that phone number, and the pattern changes, the behavior changes, and we don't have to analyze all previous history. And we have to use that parameter, and you have to delete old profiles. You really don't need them. So we're talking about death. And then the birth is also important. If you don't have data...
So we need to talk more about that when we do the design. The best is when the system can start by itself. So with empty storage, and then the system starts to fill in by itself. So this data storage, what doesn't get inscribed in the data profile storage system, so it's taken outside. So then the exterior data storage system, and which is needed as well. Then the outside data storage can be used for so enriching the profile data storage. But what when we talk about enrichment, so for example, you have so we have some certain profiles. They exist, and you get new information. And for any data scientist, it's good. It's something can be added to the existing data. Good idea. And how to do it technically, because to put a select or update for the entire so data storage profile, it's not good, because you have to turn it off, or just to make sure that it's can be connected in a hot fashion, but otherwise it may fail. And so then the same transactions that come from the production system, and then modified, and then the stored profiles need to be intact. So that's another source of data, but there should be no problems with consistency or efficiency of the data storage. And another thing, which is the last in line but not by importance, verification. Verification, because in any verification is a very important point. So for example, in case of fraud, so we make a decision, but we don't know whether we made the right decision, wrong decision. So only after a certain time we realize that good or bad. So no one just comes, claiming that they stole my money. So certainly time goes by before they realize that the money is stolen, and so that's the verification problem. So that's why the outside storage is. When your new information comes, so you need to verify to what extent the algorithms are good, and if they're not good, so they can be improved. Then the rules compression, I called it. I don't know how else to describe it. Rules compression. What's the point? So there is a certain scoring algorithm. Let's say it's a very complicated, complex algorithm, and then it gives you the result that you want. But the result that you're getting is a good bonus, because you have a training sampling, or a certain training range. So data mining algorithm or regression classification algorithms. You can find a simpler way to achieve the same result. So those who are involved in data science, so they remember that correlation does not mean causal conditioning, but correlation allows to reduce the complexity of the rules if they become too difficult. It's one of the taxi companies, a good example. So then lots of stolen cards actually started to go through the system. So they developed a new algorithm so that was catching and intercepting the fraudulent plastic cards. So then all you have to do. So if it's, for example, if there's a threshold of payment is over a certain threshold, and then it comes from a different country, then automatically, so you know that this is a fraudulent card and not to be accepted. So with simple things like that, so they immediately stopped 90% of fraud. So when so the fraudsters were trying to pay with stolen cards. And so data mining is all experimental, certainly. So it may work, may not work, and so you need just to watch the results. And so this is all I wanted to tell you. And if you have any further questions, I can take your questions later. But the main idea is that even so data mining, real-time scoring, so they're quite possible if you do the storage architecture properly, correctly. Then these things can be employed very easily and very efficiently, and even in other areas where scoring is not needed, but everywhere. So data systems, real time, and so if there is a high level of utilization, so that they can be used successfully. So the first question, what is the ground? What is the training program for classifiers? I mean, where do you take the training sampling from? It's a very difficult task, it's a creative one. So the simple option so these are the applications of users. So if anything goes wrong, so they say so. So I have had this one stolen, or just something happened there. So then we have so-called chargebacks. So when the money is stolen from the bank, so then the guy comes to the bank, so submits an application, and then they realize it was a fraud. So then the bank pays the money back to the credit card of the person from whose card the money was stolen. And but no one certainly will be writing a chargeback complaint if only 100 rubles was stolen. Now, there are other thresholds and other methods. How do you balance? So because it's balancing, so the normal transactions should be many more than fraudulent transactions. So how you do this ratio certainly is very big. No, we don't do anything special about it. So it comes naturally. So then first we did this first protection mechanism, and then we are adding more information about some more about fraudsters, about good law-abiding people. So putting some other thresholds. So this is a sustainable living system, so which is being added and improved all the time. Why don't you use MatrixNet but use Piranha? Because for Yandex to use MatrixNet will be better. So why don't you use MatrixNet? Because the tasks on hand are different, and MatrixNet for such things is too much. MatrixNet is an overkill, but here we need to be very specific in the application. And there are some technical solutions, very specific ones. I can talk offline more about that. Correct me if I'm wrong. That now this. So now the foreigners cannot get a ride from point B to point A because automatically so they will be blocked because they will make an attempt to pay with a foreign plastic card. No, so the main task is to identify fraudulent transactions, and so then. And so there's false positive definition when it's, and that's actually this system thinks it's a fraudster, but it's not a fraudster. And so we're trying to correct that. And so all types of I just told you I have told you only about several methods how to identify fraudsters, but there are many other things so which help to form the scoring and fight fraud. Thank you. And what's the level of false positive, false negative? Hmm. So this level keeps changing because the system of rules it's alive and it keeps changing. So it can even change several times a day. Yeah, but the total number of transactions. So this false positive, false negative level is very little. But I'm not going to give it exact figures, but in each specific case, it can fluctuate very drastically depending on how well the rule is written. And it balances off mostly with the help of a proper understanding, a perception of a risk. So, for example, if we identify a challenge that might take care, might lead to the loss of money and in many card holders, so then it's easy just to develop a new rule that would give more false positive, false negative, but it will save more people, and then fine tune these rules. So first is kind of carpet bombing, and then just we narrow it down and remove the excess of the by fine tuning of the rules. Now but the system of the rules, especially if rules are written not by developers but analysts, they contradict each other, and I need advice how to organize the system of rules. How just to make it simple, what approaches, how to group, how to divide, to tune better. It's difficult to answer because it's a big presentation of this system of rules. So because people who are not programmers should develop clear-cut rules that could be interpreted and optimized. By and large, the rule is like this: should have very as little excessive functionality as possible. If you want to use scripts, so we have guys who we can do that. And so Perl is a very powerful thing that can write any script, but if a non-developer gets in, it will be impossible just to figure out what he wrote, what he developed. And so that's to remove excessive functionality. First rule. And then a lot of analytics at the beginning, just to know what will be needed at a later stage. And then in different engines, so they have their own functionalities so to ensure the integrity of the system. And in Drus is very heavy, but it's powerful. But Vibro, it's simple, but Vibro is simple. But we use that too. Thank you.